Namaste everyone, welcome to the class again. In the last lecture, we have seen the Laplace transforms of the functions when it is multiplied by t. Now, in this lecture, we are going to see integrations of the functions which are of the type 0 to infinity e raised to minus at into t into f of t dt into t into f of t dt. How to find these kind of integrations? Let us see first problem. We have to evaluate 0 to infinity e raised to minus 3t into t into sin t into dt. Now, if you remember that the basic definition of Laplace transform is Laplace of f of t is 0 to infinity e raised to minus st into f of t dt. So here, if I find Laplace transform of t into sin t, it will be easy to evaluate this integral. So let us start. For that, I will first find Laplace of sin t. Laplace of sin t, the formula is 1 upon s square plus 1. Now, Laplace of t into sin t, when I multiply by t, so when I multiply by t, it is derivative, that is minus 1 into d upon ds of 1 upon s square plus 1. We can use u upon v method. So this is minus 1, derivative of 1 is 0. So s square plus 1 into derivative of 1 0 minus 1 into derivative of s square plus 1 is 2s whole divided by s square plus 1 the whole square. So minus minus plus, it is 2s upon s square plus 1 the whole square. This is Laplace of t into sin t. So Laplace of t into sin t is 2s upon s square plus 1. Now, this Laplace of t into sin t is therefore integration of 0 to infinity e raised to minus st into t into sin t into dt will be equal to 2s upon s square plus 1 the whole square. Now, we have to find e power minus 3t. So here we will replace s by 3. So put s is equals to 3. We will get 0 to infinity e raised to minus 3t into t into sin t into dt is equals to 2 into 3 upon 3 square plus 1 the whole square. This is equals to 2 3s are 6 upon 3 3s are 9 plus 1 10. 10 square is equals to 6 upon 100. So 6 upon 100 is 3 upon 50. So your answer is 3 upon 50. Simple question. Let us see one or two more questions of this type. The second question, better we consider. Okay. Let us take 0 to infinity t square into sin 3t upon e power 2t into dt. So we have to evaluate this integral. So what we will do, you can see that e power 2t is in denominator. So when I move in numerator, it will become e power minus 2t. So let us start with Laplace of sine 3t. Laplace of sine 3t. Laplace of sine 3t is 3 upon s square plus 9. Then Laplace of t square into sine 3t. This will be equal to minus 1 square into d square upon ds square into 3 upon s square plus 9. So this is equals to, now minus 1 square is 1, d upon ds, I will integrate once, so it is minus 3 into 2s upon s square plus 9 the whole square. You know how to differentiate, na? It is not required that I will teach you how to differentiate. Then this is minus 6. Now we have to differentiate s upon s square plus 9 the whole square. So it will be s square plus 9 the whole square into derivative of s is 1 minus s into, I have to differentiate this we will differentiate this s square plus 9 the whole square. So I will write 2 first, then it is s square plus 9, then I will differentiate this s square plus 9, I will get 2s, and whole divided by, we have s square plus 9 the whole power 4. You can take this s square plus 9 common, so minus 6, then this s square plus 9 I will take common. So inside I have s square plus 9 here, and here we have minus 2 to the 4 s square, divided by, this is s square plus 9 the whole power 4. So you can cancel one power and you will get minus 6. Here it is 9 minus 3 s square, and whole divided by s square plus 9 the power 3, whole power 3. So therefore I have Laplace of t square into sine 3t is equals to, now I can take 3 also common, so 6 3 is 18, so minus 18, 3 minus s square whole divided by s square plus 9 the whole power 3. So I have to find Laplace transform, that means here I have find out 0 to infinity e raised to minus st into t square into sine 3t into dt. This is equals to minus 18 into 3 minus s square divided by s square plus 9 the whole cube. Now if I put the value of s as 2, so if I put s2, I will get 0 to infinity e raised to minus 2t into t square into sine 3t into dt. This I will get minus 18. Now the value of s is 2, so this is 3 minus 4. 3 minus 4 is minus 1 upon 2 square 4, 4 plus 9, 13. This is 13 cube. So this is 18 divided by 13 cube. This is the value of, therefore 0 to infinity, I can say that t square into sine 3t whole divided by e power 2t into dt. So integration of 0 to infinity t square upon sin 3t upon e power 2t dt is 18 divided by 13 cube. Okay, you have calculator, you can write the value of this t cube. Now we have seen how we can find these integrals. Let us move to the next type, where n, instead of multiplying by t, we divide by t. So that is called as effect of division by t. Effect of division by t. Laplace of, we know that Laplace of f of t is phi of s. Then Laplace of 1 upon t into f of t will be equal to, now when we multiplied by t, we have differentiated. Now as we are dividing by t, here what we are going to do, we are going to integrate between s to infinity phi of s into ds. Now let us see the proof of the same. We have phi of s as 0 to infinity e raised to minus st into f of t dt. Now if I integrate on both the sides and take the limit of integration as s to infinity, so s to infinity phi of s ds will be equal to, here it is s to infinity, then we have 0 to infinity e raised to minus st into f of t dt, then whole ds. On this right hand side, I can interchange the limit. So it is 0 to infinity, then here it is s to infinity e raised to minus st into f of t. First I will integrate with respect to s and then with respect to t. So this will become 0 to infinity. Now f of t is constant as far as variable s is concerned. Integration of e power minus st is e power minus st whole divided by minus t. I am integrating with respect to s. Here the limit is s to infinity into dt. So this becomes 0 to infinity f of t. When I put infinity, I will get answer as 0. This minus minus will become plus, and when I put the value of s as s, so it is e raised to minus st only upon denominator is t into dt. So finally, you can see that this is 0 to infinity e raised to minus st into 1 upon t into f of t into dt. And this is nothing but Laplace of 1 upon t into f of t. So we got Laplace of 1 upon t f of t as s to infinity phi of s ds. Okay, so let us see few questions based on this type. First question we will discuss: find Laplace of 1 upon t 1 minus cos t. Now I have to evaluate the Laplace of this. So I will start with Laplace of 1 minus cos t. I know Laplace of 1 is 1 upon s minus Laplace of cos t is s upon s square plus 1. Therefore, Laplace of 1 upon t into 1 minus cos t will be s to infinity 1 upon s minus s upon s square plus 1 into ds. I hope your integration part is very good. So if you integrate 1 upon s, you will get log s minus here you can adjust 2 in numerator and denominator so that your numerator become derivative of denominator, and you can say this is log of s square plus 1. Limit is s to infinity. Now this is log of if I take 1 upon 2 common, this is log of s square divided by s square plus 1, and limit is from s to infinity. When we put infinity, the answer will be 0. So here it is 0 minus log of s square upon s square plus 1. So as negative sign is there, I will say that this is 1 upon 2 log of, I will reciprocate it, it will be s square plus 1 upon s square. This is your Laplace transform of 1 upon t into 1 minus cos t. Let us discuss one more question. We have to find Laplace transform of e power minus 2t into sine 2t into cos hyperbolic t upon t. So here this cos hyperbolic t, what we can do, we can put the value of cos hyperbolic t in terms of e, so it will be e power minus 2t into sin 2t upon t into this cos hyperbolic t can be written as e power t plus e power minus t whole divided by 2 into dt. So this will become not dt, we have to find the Laplace, so it is Laplace. So this is equals to Laplace of this is Laplace of, now if I open the bracket, 1 upon 2 I can take out, this is e power minus t into sin 2t upon t plus e power minus 3t into sin 2t upon t. So we can apply first shifting theorem and then application of division of t. So here Laplace of, I will consider this as equation 1. Now Laplace of sin 2t, Laplace of sin 2t is 2 upon s square plus 4. Then Laplace of sin 2t divided by t. So here we will get s to infinity 2 upon s square plus 4 into ds. Now integration of 1 upon a square plus s square is 1 upon a, so that is 1 upon 2 into 2 upon 1 upon a into this 2 we will take as it is into 2 into 1 upon a into tan inverse s upon n. So tan inverse s upon 2, and the limit is s2 not defined. So this 2 to cancel. Tan inverse not defined. Tan inverse not defined is pi by 2. So it is pi divided by 2 minus I have tan inverse s divided by 2. So therefore Laplace of, now I will use the first shifting theorem. So Laplace of, we have e power minus t, Laplace of e power minus t into sin 2t upon t is equals to, it will be pi upon 2 minus tan inverse, here s will replace by s plus 1 upon 2, and Laplace of e power minus 3t into sin 2t upon 2, this will be equals to pi upon 2 minus tan inverse, here s is replaced by s plus 3 upon 2. So therefore 1 upon 2 into Laplace of e power minus t into sin 2t upon 2 plus e power minus 3t into sin 2t upon 2, this will be equals to 1 upon 2 pi by 2 minus tan inverse s plus 1 by 2 plus pi by 2 minus tan inverse s plus 3 divided by 2. This is equals to, we have 1 upon 2. Now pi by 2 plus pi by 2 is pi minus tan inverse s plus 1 divided by 2 minus tan inverse s plus 3 divided by 2. So therefore Laplace of this whole term is nothing but Laplace of e power minus 2t into sin 2t into cos hyperbolic t whole divided by t is equals to, this is equals to, what I can say, pi by 2, I will open the bracket, minus 1 by 2 tan inverse s plus 1 divided by 2 minus 1 by 2 tan inverse s plus 3 divided by 2. Okay, done, right? So I will stop lecture here. We have seen few questions of property where we divide the function by t. In the next lecture we will see few problems in which we will find the integral and which the function is divided by t. Thank you.